Welcome to our comprehensive presentation on petroleum. In this session, we will delve into the intricacies of petroleum, often referred to as crude oil, discussing its composition, processing techniques like fractional distillation, and its significance in various industries. We will also explore cracking, reforming, and the production of petrochemicals, along with the concept of the octane number and how it affects petrol quality. Petroleum, or crude oil, is a naturally occurring liquid found beneath the Earth's surface. It is a complex blend of hydrocarbons and organic compounds and serves as the backbone of modern industrial processes. From fueling vehicles to forming the basis of various chemicals, petroleum is an indispensable resource. The composition of petroleum is diverse. It primarily consists of hydrocarbons, which include alkanes, cycloalkanes, and aromatic hydrocarbons. Additionally, petroleum contains non-hydrocarbon compounds like sulfur, nitrogen, and oxygen compounds, which can impact its refinement and use. Petroleum exploration is a critical initial step in the petroleum industry, aiming to discover new reserves of crude oil and natural gas beneath the Earth's surface. This process begins with a geological survey, where experts analyze surface features, rock samples, and geological maps to identify promising regions that might contain petroleum. The next stage is the geophysical survey, which employs advanced techniques like seismic, magnetic, and gravity surveys to gather detailed data about the Earth's subsurface structures. Seismic surveys, for instance, involve sending sound waves into the ground and analyzing their echoes to map out potential oil-bearing formations. Following these surveys, the process moves to exploratory drilling, where wells are drilled to confirm the presence of oil or gas. These wells, often referred to as wildcat wells, help assess whether a region contains commercially viable petroleum deposits. If oil is found, the next step is appraisal drilling, which involves drilling additional wells to determine the size and economic value of the discovered reserve. This comprehensive exploration process is essential to ensure that the petroleum extracted will be profitable and sustainable, guiding future development and extraction efforts. Fractional distillation is an essential refining process that breaks down crude oil into its various useful components by leveraging their differing boiling points. The process begins by heating the crude oil to around 350 degrees Celsius, which vaporizes the majority of its contents. This vapor is then introduced into a fractionating column, a tall tower with numerous levels equipped with trays or plates. As the vapor rises through the column, it cools gradually. Components with higher boiling points condense on the lower trays, while those with lower boiling points continue to rise, condensing on higher trays. This systematic separation allows us to collect fractions like refinery gas, gasoline, kerosene, diesel oil, lubricating oil, and bitumen at various levels, each serving distinct industrial purposes. The continuous operation of the fractionating column ensures an efficient and steady production of these vital products. Fractional distillation of petroleum results in the separation of several key fractions, each with specific applications. Refinery gas, which has a boiling point below 20 degrees Celsius, is primarily used as cooking gas and fuel for gas stoves. Gasoline, distilling between 40 and 100 degrees Celsius, is a vital fuel for cars and also serves as a precursor for manufacturing chemicals such as plastics. Kerosene, with a boiling point range of 150 to 250 degrees Celsius, is utilized as jet fuel and for domestic heating. In many rural areas, it is still used for lighting in kerosene lamps. Diesel oil, which distills between 250 and 350 degrees Celsius, powers heavy-duty vehicles like trucks and buses, making it essential for transportation and logistics. Lubricating oil, with a boiling point above 350 degrees Celsius, is used to reduce friction in machinery, enhancing the efficiency and lifespan of engines. It is also a base for producing waxes and polishes. Finally, bitumen, the heaviest fraction and a residue from distillation, plays a crucial role in road construction and roofing, providing a waterproof layer and structural integrity. Let's test your understanding so far. Choose the correct option for each of the following questions based on the content we've covered. Cracking is essential in the petroleum industry to convert heavy, less useful hydrocarbons into lighter, more valuable products. There are two primary types of cracking: thermal and catalytic. Thermal cracking involves exposing hydrocarbons to extremely high temperatures and pressures, leading to a mix of smaller alkanes and alkenes. Catalytic cracking, on the other hand, employs a catalyst like zeolite, operating at lower temperatures and pressures, and is more efficient in producing high-demand alkenes such as ethene and propene. These products are vital in manufacturing fuels and a range of petrochemicals. Reforming is another critical process in refining petroleum, aimed at improving the quality of gasoline. This process involves the conversion of straight-chain hydrocarbons, which have lower octane ratings, into branched-chain hydrocarbons and aromatic compounds with higher octane numbers. Utilizing catalysts like platinum or chromium oxide, reforming takes place at moderate temperatures. One of the significant benefits of reforming is the production of high-octane fuels that minimize engine knocking, enhancing overall vehicle performance. Additionally, the hydrogen produced as a byproduct is used extensively in other refining operations and industrial chemical processes. Petrochemicals are invaluable derivatives of petroleum, forming the basis of many products, from plastics and synthetic fibers to rubbers and fertilizers. These compounds are integral to various industries, showcasing the versatility of petroleum beyond fuel. The quality of petrol is often gauged by its octane number, which is a crucial indicator of the fuel's ability to resist knocking during combustion. Knocking, or pinging, occurs when fuel burns unevenly in an engine's cylinders, leading to potential engine damage and reduced performance. A higher octane number implies better resistance to knocking, ensuring smoother engine operation and improved fuel efficiency. For instance, isooctane, a highly resistant hydrocarbon, is assigned an octane number of 100, making it a standard for high-performance fuels. In contrast, N-heptane, which is prone to knocking, has an octane number of 0. To enhance the quality of petrol, several methods are employed. Blending involves mixing fuels of different octane levels to achieve a desired performance characteristic. Additives, such as ethanol, are introduced to increase the octane rating and improve combustion efficiency. Reforming, on the other hand, chemically alters the structure of hydrocarbons, increasing the proportion of branched and aromatic hydrocarbons, which inherently have higher octane numbers. These techniques collectively contribute to producing petrol that not only performs better, but also ensures the longevity and efficiency of automotive engines. Now, let's evaluate your understanding of the content related to cracking, reforming, and petrochemicals. Select the most appropriate answer for each question. In summary, petroleum is an essential resource composed of various hydrocarbons and compounds. Through processes like fractional distillation, cracking, and reforming, we derive numerous fuels and petrochemical products. The octane number remains a vital measure of petrol's quality and performance. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.